Alright, welcome back everyone. In this video we'll be introducing the derivative and how to find the derivative and really what it means. So this time I'm using this new really one-note method of teaching. I have a pen and I'm just exploring different ways to teach. So let's start off with what is a derivative. I apologize, my handwriting is not the best, but alright. So what is a derivative? A derivative is essentially just finding what the slope is of a line. When you hear the word derivative, I want you to immediately think of slope. So with straight lines, it was very easy to find the slope because the line has the same slope at every point. We would solve a straight line's slope by looking at its equation, y equals mx plus b, where m is the slope. And the slope is the rise over run. So in this case, it looks like this line I drew had a slope of roughly 1/2, up 1 over 2. But what derivatives will give me is an answer to what is the slope at any point on this line. So here I drew a parabola. This looks like it's y equals x squared. And when we find the derivative of this function of y equals x squared, we will get another function that describes the slope at any point. So this extra function, we can call it y prime, or if you define this function as f of x equals x squared, it's f prime of x. This is the notation used for derivatives. And there's a couple different ways that you can represent a derivative, but this is one of the most common ways, f prime of x. So this derivative function will give you some function of x where you can plug in a value of x and find the slope. So if we plugged in -2 into this value of f prime of x, we would get the slope of the line that intersects the function x squared, or f of x equals x squared, at the point x equals -2 on this line. And I didn't draw this very well, but this line passes very close to this function of x squared, but only touches the line at x equals -2, or it's tangent to the function at the point x equals -2. None of the points next to that point touch it, just one single point. So that's the big picture view of what a derivative is, and really what it's used for is just finding the slope. Again, think derivative is slope. So how do we do this? How do we find this f prime of x when we have the function f of x equals x squared? So I'm going to show you the definition I learned when I first learned about what a derivative was, and that is this. F prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Now I'm not going to go into detail on why this function here is true, or this definition is true. There's plenty of YouTube videos, they're a dime a dozen, on explaining where this came from and what it means. All I'm going to show you in this video is practice problems on how to use this. So we had the example of y equals x squared. So let's use this definition and find the derivative of f of x equals x squared. Alright, so I'm going to split this definition up into 3 parts. Actually, I'll keep black for a second. So the first part is the limit. The limit as delta x approaches 0. The next part is this f of x plus delta x. The next part is minus f of x. And then we're dividing all of this by delta x. Alright, so let's focus on the part in blue first. What is f of x plus delta x? So our definition of f of x here is that f of x equals x squared. If we plugged in the value of 1, we would get f of 1 equals 1 squared, or 1. Here we are plugging in x plus delta x instead of x. So this top part is just going to be x plus delta x squared. And actually I'm going to put the limit back down because that won't change. So rewriting this, we have in blue x plus delta x squared minus f of x divided by delta x. Now this red part, f of x, this is just our definition of f of x, which is x squared. So we'll plug that in. And now we have to solve this limit. So if we just plugged in 0, like we would do with the limit, if we're the first step of solving a limit is always just trying to plug it in. If we plugged in 0, we would get some value on top divided by this value on the bottom of 0. 0 would go in for delta x, and we would have a fraction divided by 0, which we can't do. So we can't just plug it in. So what I'm going to do is I'm going to expand this blue part here. I realize I can also just point my pen pretty close and it has a little marker. This blue part here, we're going to expand that. So this is going to equal the limit as delta x approaches 0 of, so expanding this square, so we have x squared. We're going to have delta x squared on the opposite side. And then in the middle, we have delta x times x. So this is x delta x. And we're going to have that twice, so 2x delta x. Now on the left-hand side, we'll still be subtracting x squared. And on the bottom, we will still have delta x. I'm not going to write in green this time. Alright, and we can simplify the top because we have x squared and we have a negative x squared. So they will cancel each other out. We will be left with the limit as delta x approaches 0, 2x delta x plus delta x squared divided by delta x. And now we can actually cancel the delta x in the bottom because both pieces of our equation on top have a delta x. So that will cancel and only one of these will cancel because this is squared. And we are left with the limit as delta x approaches 0 of 2x plus delta x. Now this limit is much easier to solve because we can just plug it in. So delta x approaches 0 means it equals 0. And we are left with our answer of 2x. 2x is the derivative of x squared. Now there's a much easier way to do this with derivative rules, but just for the sake of learning this, if you're learning this for the first time, this is a helpful exercise to go through. Alright, let's try one more. Let's try to solve f of x equals, make sure this, okay, it still lets me go down. F of x equals x cubed minus 3x. And let's remember our definition, the limit as delta x approaches 0. This is f prime of x equals of f of x plus delta x minus f of x over delta x. Alright, So we'll do the same thing we did before. We have to plug in our function into our definition. So limit as delta x approaches 0, and I'll use colors again for this. So I used blue last time for this piece. X plus delta x. So using our definition, we're going to plug in x cubed minus 3x. Or excuse me, we're going to plug in x plus delta x into this function of x cubed minus 3x. So that will equal x plus delta x cubed minus 3 times x plus delta x minus, and now we still have to put in our actual function because we're subtracting f of x. So minus x cubed minus 3x, and this is subtracting from the entire function, so we don't want to get mixed up with these negatives. All over delta x. And this is where it starts becoming a pain, because this is going to be a lot of algebra to expand these and cancel it. But we're going to do it anyway, because sometimes life sucks. Okay, so x plus delta x squared times x plus delta x. So first I am expanding this top piece here, and we're going to multiply it out. And I should have written that in blue. Just pretend this is written in blue. So this first piece here is x squared plus 2x delta x plus delta x squared. And we're going to multiply this by x plus delta x. And again, I'm just looking at this piece. I'm just expanding that piece. We'll get to the rest of this later. Alright, and we have to multiply this out now. So I'm going to use the FOIL method. So x times x squared is x cubed. X times 2x delta x is 2x squared delta x. X times delta x squared is x cubed delta x. Now delta x times x squared is x squared delta x. Again, this is a pain. You just have to do it. You just have to power through it. Plus 2x delta x squared. Finally, plus delta x cubed. This is a lovely equation. Okay, so let's see if we can combine anything, and it looks like we can. So we have something here with x squared and a delta x, and an x squared and a delta x. So it looks like since we have two of these here and one of these here, we now have 3. So this whole thing is going to equal x cubed plus 3 x squared delta x. And now we also have, let's see, that might be all we can do. Delta x squared. I'm just double checking. Yeah, that's all we can do. So 3x squared delta x plus x. Wait, did I screw this up? Let's see, so I had x squared times x is x cubed. X times 2x squared, yep. X times, oh, yeah, this should not be that. This should be x delta x squared. Okay, so we can combine these. Sorry for that. So we have 1x delta x squared, 2 x delta x squared. So as you can see, the same thing I did before. So we have one of these, and we have 2 of these. We now have 3 of these. So plus 3 x delta x squared. And plus delta x cubed. Alright, so that was this piece here. So I'm going to rewrite this and plug in what we found for this. So we had the limit, that did not work. the limit as delta x approaches 0 of x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. And now let's see what we were missing. So we also have this piece here, minus 3x plus delta x. So minus 3x plus delta x. And I'm going to run out of room here. Oh, I can move it over. Okay. And then minus x cubed minus 3x. Minus x cubed minus 3x. And this whole thing is going to be over delta x. Alright, we can simplify it just a little bit further, and then things will start to cancel. So I'm going to rewrite this down below. So the limit as delta x approaches 0 of x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus 3x, and I'm distributing this minus 3x across this, so minus 3x minus 3 delta x. And now I'm also going to distribute this negative, and we're going to get plus x cubed, or sorry, excuse me, not plus, that one's going to be a minus x cubed plus 3, all over delta x. And now we can cancel this x cubed. So we have an x cubed and a negative x cubed. So that's pretty convenient. Is there anything else we can cancel? So we got a minus 3x. Let's see. Oh, excuse me, that is a minus, that is a plus. See, when you do these problems, it's easy to make a mistake just because there's so many pieces to the equation. So that's a plus 3x. So this plus 3x can also cancel with this minus 3x. And now let's rewrite what we have left. The limit as delta x approaches 0 of 3x squared. Actually, I'm going to do something different. I'm going to write these delta x's in green. Delta x plus 3x delta x squared plus delta x cubed minus 3 delta x. And this is going to divide by delta x. Now I marked the delta x's in 3 just to make it easier to see, or in green just to make it easier to see, that each piece on top now has a delta x. So we can cancel the delta x's. So that will become a 2 and delta x. And we are left with the limit as delta x approaches 0. Sorry, my deltas are getting very lazy. Of 3x squared plus 3x delta x plus delta x squared minus 3. And now we can just plug in the delta x equals 0. So that will be 0 and that will be 0. And we are left with 3x squared minus 3. That was quite a lot just to take this derivative. And once you know derivative rules, the function that we started with, you'd be able to do this in your head. So there's a reason why you don't really do it this way, but again, a lot of calculus courses just want you to go through the heavy work just for a little bit of experience and perhaps some appreciation and how a derivative was how the derivative method was discovered. Alright, I think I'm going to stop it there for that video. We'll move on into derivative rules, and really the rest of the series is just going to be practicing derivatives. I think at the end I'm going to touch on integrals just a little bit. But yeah, moving forward it's going to be a lot of derivatives and just practicing using the rules. Alright, thanks.